So we'll continue. And before continuing with this intermediate code generation, yesterday we have started the intermediate code generation. Okay. So I told you with one example I will differentiate between all the errors, lexical, syntax, semantic, and no compiler error and a linking error, all I will tell you. Okay. Now look at this one. This one. Only A, the program A. You just tell me what kind of error, the earliest error. What is the earliest error that can be produced by the compiler? The earliest error that can be produced by the compiler. Are you following? Void main, open parenthesis, int A equal to 0, semicolon. If A equal to 0, then printf the cd, and this is okay. Now what is the earliest error that can be produced by the compiler? Okay. Now look at this one. Here everything will be converted into token. This is, and whenever double quotes open, the lexical analyzer will searches for the closed double quotes. Here double quotes is open and no double quotes closed. Means closed double quotes. There is no closed double quotes. So this is unmatched string. Unmatched string. Are you following? Unmatched string implies lexical error. Lexical error. Okay. Unmatched string, lexical error. Copy this one. Make it fast. And yesterday I forgot to send the notes to one student. That student told me he missed it from some part of dictation. Sorry, today I'll send. And if you already copied, it's okay. They have texted me in the WhatsApp also. Now, copied. Now we'll go for. I'll change this code. So this is a lexical error because it is unmatched string. Okay. Now what is the earliest error? What is the earliest error that can be produced by the compiler for this code? The same code, earliest error. How to contact you on WhatsApp, sir? WhatsApp install करो, ओके, मेरे नंबर सेव करो, मैसेज भेजो, मेरे को आएगा मैसेज. गौरव कुमार, समझ गया? Ankan Mukherjee, sir, this is my first class. I joined today. Okay, welcome. Wait for some two more days. Okay, other faculty will come. Anyway, you can understand these concepts. These concepts are easy and they don't depends on the previous topics. No, not this one. whatever I am going to start in another 5 minutes, that is intermediate code generation, that you can understand easily, okay, even though you are new student. Okay. So, what is the error in this earliest error? There is no syntax error, everything can be converted into tokens. So, there is no lexical error, no lexical error. Okay. And moreover, have you observed, if is not a keyword, if is a keyword, IFF is not a keyword. So, whenever it is, so here if will be considered as a function name. If will be considered as a function name, whenever you are calling a function, it must be terminated with the semicolon. It must be terminated with the semicolon. But here, no semicolon present. No semicolon present. So, it is syntax error. It is syntax error. Okay. So, as if will be considered as a function name, okay, and you are calling the function, and then it must be terminated with a semicolon. But terminated, the semicolon, I have not given the semicolon, okay, it has to be terminated. I am saying here, you don't write semicolon, because it is not ending with semicolon, it is a syntax error, okay. Then come to this next code B, next code B. Gaurav Kumar, just kidding. Okay, already I have shared my number. You can, anyway, I'll give again. Ankan Mukherjee, yes, they, I think OS, TOC, some DBMS, some 3 topics, I think 3 subjects finished. No, don't worry. These all subjects again will be come in the once all the subjects are completed in the cycle, you can get. Even you will have CD also for new joiners. Now, look at this B. Here everything can be converted into tokens, so no lexical error, no lexical error, and even syntax also, everything here open parenthesis, closed, open braces, closed braces, open braces, closed braces, and string and this statement ending with semicolon, this function call is also ending with semicolon, and this printf is also ending with semicolon, and this is a matched string, so no lexical error and no syntax error also, no syntax error, okay. And if will be considered as a function in the syntax analyzer, so it will pass through the semantic analyzer. See, it completely depends on the language. If you run the same code, I think C++ won't give you error. C++. C language will give you error. So whenever you are calling a function, that must be either defined before calling, it must be defined, or at least it must be declared. Either declaration or a defined must be there before calling. So here we have not defined, even we have not declared. Are you following? If will be considered as a function, so it must be defined, either defined or declared before calling. No defined, no definition, no declaration. Therefore, it is semantic error. Semantic error. It will be run successfully in the case of C++. You can just see all these errors. You just write the code and run, and you see in your systems. It will tell you what kind of errors. Of course, semantic error, lexical error, syntax error, it won't differentiate like this, but it will tell you whether error is there or not. Okay, so it is semantic error because if it is not declared or not defined. Copy that. Done. Now come to C. This one, this code. Same code. I am doing small changes in all these codes. I am calling, I am not writing the function, I am calling the function. Kundan Kumar. Okay, Gaurav Kumar, you also first class. Hello. Many students. Many are there. Okay. So Gaurav, you also knew. So some C languages, based on the compiler, they will give you some errors. Okay, so if you are eagerly means know this subject, you can watch the recorded videos. Otherwise, you have to wait until the next cycle. So I don't know about your answer for your question, Patel Kushi. You just contact the management. In general, actually it is depends on the design. In general, I am giving you some compiler. Actually, one person has recent languages. So majority of the languages, which kind of parsing techniques are using, somebody has asked me. So recursive descent parsing, that time I told you, recursive descent parsing being used. And earlier they were using LLRFN parser. LLRFN parser was used, and now recursive descent parsing is mostly being used. And this is, we have different compilers. So in general, so before calling a function, it must be declared or defined. Here we have declared. Okay. Here we have declared. And before main function we have declared. But we have not defined. Are you following? We have not defined. Just we have declared. Then main, no, here just if you look at this one whole, there is no lexical error. No syntax error also. No syntax error, and even no semantic error, because we are calling this, and before calling we have defined as if as a function name, function. Okay, and so no before calling declaration is also done. So no lexical, no syntax, no semantic. So you can say no compiler error. Okay. Now, so after compilation, linking will come. So at the time of linking, it links all the functions. So means standard functions with library, it searches with the library, and user defined function, it will searches for the definition. So here if is a user defined function, here it is a user defined function, this is user defined function, but its definition is not there. Are you following? So function, it can be a standard function or user defined function. If it is standard function, it will be available in the its definition will be available in the library, but it is not a standard function, it is user defined function. So the linker searches for the definition, there is no definition for the if, so it is linking error. Linking error, do you understand? Linking error. Now okay, so come to this one, come to this code, come to this. So lexical, syntax, semantic and linking. See, actually whatever you run, it will show you as a syntax error in your system. It won't tell you lexical, syntax, semantic, linking like that. Govind Mishra. Okay, whenever you are giving the answer, yes, you mentioned that this is a C program, this is D program. So you are giving the answer, and I am unable to understand, identify for which one you are giving. Okay, now come to this one. Here declaration is there and everything is perfect with the lexical analyzer and syntax also perfect, and semantic, here we are calling, before calling we have defined. So simple. Remember this in your mind, that whenever you are using a function, it must be declared or defined before using the function. If it is not declared or defined, it will throw as a semantic error. Completely it is all depends on the language. Okay, but in general the C language, old language I am talking about. So whenever you are calling a function, it must be declared. Yes, it is declared. So when it is declared, no semantic error. Okay, no compile error. Coming to the linking phase, whenever a function is there, user defined function, it must be defined. Yes, it is also defined. So no linking error, no linking error, no compare error. It is no linking and no compiler, no compiler error. So if you are using the different compilers, so same code can give the different errors for different compilers, because I have tried this already. Okay, so this is, so remember this in your mind, that so you know what is lexical error: unterminated comments, unmatched string, invalid constant, invalid identifier. Okay, and illegal characters, whatever the language that does not support, if you are using. So these are the lexical error. Syntax, you know, according to the syntax of the language, if it is not satisfying the syntax of the either keyword or language, whatever, then syntax error. If everything is syntax is perfect, then coming to semantic analyzer. Semantic analyzer, if you don't define a variable, or if you don't declare a function, or if you are using different arguments when in the definition or in the calling, So, formal arguments and actual arguments are not matched, then also semantic error. And there is no semantic error, means declaration is there but definition is not there. Definition is not there but declaration is there. No semantic error, no compiler error. Then it come to linking phase. In the linking phase, it will search for the definition of the function. Definition is not available, then linking error. Even if linking is there, means if definition is there, then linking will also no error. See, no linking error because definition is there. Then what can be the error? No compile error, no linking error. Then what can be the error? It can be a runtime error. It can be a logical error. Okay, these errors can be happen. Are you following? If no compile error, no lexical error, no compile error, no linking error. Linking error means definition of the user defined function is also there. Then no linking error. Then what error you can get? Then you may get the runtime error or that logical error like this. Okay, so this is about the errors. We will go to this one. We were using 3 address code. We were at the 3 address code in yesterday's class. So in 3 address code, in any statement, maximum 3 references will be there. 3 variables will be there. 3 variables. Somebody is asking, what is this operator? Okay, so he has not understand this. What I was telling this one. So any statement, maximum we can use 3 variables. So like this. And what is operator? Anything like A equal to B plus C or B star C or B minus C or B divided by C, like that. Okay, other than this, okay, A equal to will be there. Equal will be there. Other than equal, you can use only one operator. What I mean to say is, suppose A equal to B star C plus D. So, other than equal to, how many operators we have? 1, 2. This is not a 3 address code statement. This is not a 3 address code. So, on the right side of assignment, maximum you can use one operator. So, you can understand this one. On the right side of assignment, here 1, 2 are there. It is not a 3 address code, and moreover 1, 2, 3, 4 operands are there. Maximum 3 operands only, and 3 variables only. 3 variables, maximum 3 variables, 2 for operands and 1 for result. 1 for result and 2 for operand. This already I have explained yesterday. Okay, now coming to, there are some valid 3 address code statements. Some of them I am giving you. What are the valid 3 address code statements? Example, first one. X equal to Y operator Z. It is a relational assignment statement. X equal to Y plus Z or Y into Z, like this. X equal to Y operator Z. This is a relational assignment statement. And X equal to operator Y. This is also assignment statement. And X equal to Y. Simply just copy statement. X equal to Y operator Z. You can use this one. You can use this one in the 3 address code. You can use this is also. And if relation, example, if A less than B, then go to L. Some go to 10 or go to 1, like this. Okay, if condition is true, if some relation, whatever condition, if condition is true, then jump to the L statement. Then this is called conditional jump. Whenever this statement, if A less than B, it become true. Okay, if it is true, what is if condition? True or false? Boolean. So if it is true, then jump to first statement, like that. And if Z. So actually, if this is true, if I write if Z means if A is not less than B, then go to 1. Do you understand the meaning of this one? Here, if A less than B, if A is less than B, then jump to 1. Conditional statement. Instead of if I write if Z A less than B, means if condition is false, then go to 1. Do you understand? So if Z and if here condition is true, go to L. Here if Z condition is false, go to L. And this is go to L. That means without condition, directly jump. Okay, in the sequence, this is the sequence of the statements. And here I wrote go to 100, means without any condition, it jumps to the 100 statement. So that is the meaning of this. Wherever 100 is there, it will jump to without any condition. It is unconditional jump. These two are the conditional jumps. This is conditional, this is conditional. And here array indexed assignment, A equal to B of I, A of I equal to B. And address assignment, A equal to ampersand B. And A equal to star B and star A equal to B. These are the pointer assignment statements. So you just copy this. I will explain the remaining later. Copy this. Linking error means if function is declared and no semantic error, at the time of linking, the linker will searches for the definition of the function. Here if you see the previous one, we have defined the function here. The definition is here. So definition is there. Then there is no linking error. If definition is not there, if you see this one, here if you see this one, we have defined, we have declared, but not defined. So whenever you declared no semantic error, no compile error, at the time of linking, it will searches for the definition of this function. The definition is not available, then it is linking error. So different languages will execute differently same code, that depends on the compiler and versions of the compiler also. Because earlier I have tried all these. So some compilers giving some errors and some compilers not giving errors. Last one error is no error. So copy this one. Ankan Mukherjee, now I am in intermediate code generation topic. Basics of compiler, lexical analysis, syntax data translation. The major topics are completed and almost subject is going to finish in next 2 days. Today this topic will be completed and tomorrow code optimization will be completed and day after tomorrow runtime environment will be completed. So these 3 days are the last days of the subject. Okay. Ayush Maheshwari, Zoom call I am planning to conduct in the evening 4 to 5:30 that time. 4 to 5:30 Ayush Maheshwari on Friday. It is not a valid 3 address code, Praveen Kumar. Okay, done. So on the right hand side only one operator maximum valid, maximum one operator. Copied. So this is unconditional, these two are the conditional. These two are the array indexed assignment. This is address assignment, this is pointer assignment. Now param is a function. Param is one instruction. So param x1, param x2, param x3, so on, param xn. The arguments to the procedure P. Suppose when the name of the procedure is P. The arguments to the procedure P. The arguments to procedure and function calls are defined by the param instructions. Okay. Params are placed in the stack. So all these will be placed in the stack. Now call P comma n. This is the invocation of the procedure P. The name of the procedure is P. An invocation of procedure P that takes n arguments. After calling this one, whatever the you store in the parameters, whatever the parameters store in the stack, they all will be cleared from the stack. This is call P comma n. P is the procedure name and n is the number of arguments or n arguments. So an invocation of procedure P that takes n arguments. Okay. After the call to P, then after call to the P, the n parameters are cleared from the stack, means removed from the stack. Okay. So this is the calling invocation of the procedure with n arguments, and these are the instructions, param instructions. So param x1, param x2, param xn, these all x1, x2, xn will be placed in the stack, and this is invocation of the procedure. And return passes the control to the instruction following the call instruction. Example, param x1, x2, x3, so on, param xn. and call PN, and after this we have written some instructions, and now return. Return means passes the control to the instruction following the call, here call. So this whenever you write return, the control will be goes to the next instruction wherever call the function wherever call is invocated. It passes the control to the instruction following to the call instruction that invoked the procedure. Wherever we call the procedure for whatever the next instruction, it will go to this whenever you write the return. Okay, and return x means passes the control to the instruction following to the call instruction. Okay, and the value of x is returned. The value of x is returned is just the control will goes to the next instruction of the call, whereas here return, it will the function of return x is as return, and also the value of x is returned. I wrote here, it is just copy. Passes the control to the instruction following the call instruction that invoked the procedure, and the value of x is returned. The value of x is returned, and this is exit. Exit takes no arguments, just it exits from the program. So these are the some instructions, these three address code instructions. There are some more, you can see them. So mainly whatever used, and even we don't use maximum, we use these, and very rarely you can see param instructions. Okay, so copy this one. So Zoom call, we cannot satisfy all of you, because it is not the strength of 10 to 20 members. Many students are there. So every student, so anytime I say, that time may not be possible to at least somebody. So how can I satisfy everyone? So I must keep the Zoom call in the midnight, like around 11 o'clock, midnight, 11 to 12 or 11 to 1, like that. So how it is possible? So Zoom call, it is a 5 or 5:30 or Sunday. Okay, anyway, I will take your request. I will talk to the schedule team. If it is possible, I will take the Zoom, but Sunday is not possible for me. Sunday is not possible. I must take any other day. That must I take from my home. See, because if I finish this, then my part will be finished. I must finish this Zoom meeting. Okay, I do one thing. I will try to arrange one more meeting from my home, but let me finish one meeting by Friday. But most probably we will have the meeting on Friday either from 4 to 5:30 or in the morning. Abir Karmakar, okay? Kundan Kumar, if C we are passing Boolean value, that is if is a IFF. It is not a if condition. IF, then it will be a Boolean. It is IFF. How if can pass a IFF is a function name. If it is IF, then it can take the Boolean. So just check this one. Kundan Kumar, Yatin Singh, and I see I can tell you what are the outlines, but in depth of the program I cannot. The programming I am not strong. Okay. Now, so workbook syntax analysis will be part will be uploaded today. By the time our class is finished, I think it will be available. The workbook solutions based on the syntax analysis, and I have explained almost every questions. I think I left one question, one or two questions I left. I gave the answers also for that, but it is means repeated question, which you can do, which I feel that you can do easily. One question I think I left. I gave the answer, but I didn't do. That is numerical questions. Okay. Now, next we will see how to write 3 address code for the statements or expressions. Take the question. Write a 3 address code. Write a 3 address code for the following statements. Write a 3 address code for the following statements. Write a 3 address code for the following statements. Everybody copied this one, or still anybody has still copying this part? Copied? So today we will complete this topic. It is already 7. Okay. Now, write a 3 address code. Very simple question I'll give you. Very simple question. X equal to A plus B star C plus D. Simple question. And suppose here minus the star is the highest priority. You just take it as star is the highest priority. Then plus is the next highest priority. Then minus is the least priority. So star is the highest priority, plus is the medium priority, and minus is the lower priority. You just consider like this. Then write the 3 address code for this. Okay, I am writing this one, and you can write this simultaneously. So it is the highest priority. So I will take T1 equal to B star C. You look at this one. In this we are taking 1, 2, 3 variables maximum, and one operator only other than this equal to. But whereas here 1, 2, 3 are there. Then we have this in T1. Next priority is A plus. So what I do, I will take T2 equal to A plus T1. Okay. Now this result, this A plus B star C we have in T2. Now T2 minus D we required. T2 minus D. Okay. T2 minus D, which we store in X. So if you look at this one, it is the expression, single expression. For this single expression, we have written the 3 address code, and in every 3 address statement, maximum 1, 2, 3, 1, 2, 3, 1, 2, 3, 3 variables, and maximum 1 operator other than this assignment. So this is the 3 address code. Okay. So now same expression I will give you, but I change the question. Same expression I will give you. This is first example, and second example. X equal to A plus B star C minus D. I am giving you the same expression. I am not changing the expression. And condition I am giving, where X comma A are real, and B, C, D are integers. B, C, D are integers. So try this one. Okay, try this one. You know that what is the 3 address code we have done in the first class. So I need not to say this one again and again. It's simple. And this both are same. Here no condition, and here also you take this B star C and minus D, and plus and minus here you don't have any problem, and star you take as the highest priority. star you take highest priority, and plus and minus say equal priority, no problem, because we don't have any whether you do this then this one or this and then this one, you will get the same answer. You will get the same answer only, no problem. So, but take star as highest priority. So, copy this one and try. No error, T1 and you can use that same T1 and again, but the thing is it should not change. Of course you can use. See, the question is like this, they can ask you the minimum number of temporary variables, that can be used in the 3 address code for the following statement. So first T1, okay, then T1 is B star C. We add A and T1, we will place in T1. Then this whole is in T1, and finally we want T1 minus D, T1 minus D. This is also correct. And at the same time, if you want the same code in SSA form, then the previous one is correct. Whoever asked this doubt, T1 repeatedly you can use until it should not change the value. Of course, here the expression final value won't be changed, and this is valid in 3 address code. But if they mention that SSA form, then this is invalid. So what is SSA form, we will see later. Okay. Now this is correct, but this is correct. Ayush Vasishta, how can we convert L attribute grammar to S attributed grammar? There is one question in the workbook, so you can see that L attribute grammar, simple boss. This is, who is this? Ayush Vasishta. If I see the you are chatting in between, this is the problem. Okay, simple. I suppose something here, and here I here I have given that S derives A and some print A something A dot value or something. Print A dot value, something I have given, then followed by B. Okay. So what I do here, this is no doubt it is a L attributed SDT, because in between you have, I want to convert this into S attributed SDT, means S attributed must be placed at the end. So what I do here, I will introduce a new variable. Suppose this is AA or some, let it be ABC. Okay, I'll take ABC. This is A, B, C. Okay. So I will introduce, here I want to print na. So the output should not be changed. So what I do, I will introduce ABC, I will introduce a new variable X, and so that this X should be epsilon, because see the production should not be changed. ABXC, what is the X value here? Epsilon. When you substitute epsilon, what will be the production? ABC only na? You are getting ABC only. So production is not changing, and moreover, see A, B, now here epsilon is reducing. So what I do, I'll write like this: S derives AAB. I don't write any semantic action here. But I write What is the production here? S there is AB. S there is ABC is the old production. What is the new production? S there is AB XC. Are you following? This is the old production. S there is ABC. S there is ABC. Unnecessarily I changed this. This is the old production. S there is ABC. And AB after you are taking the action. Action is performed here. Action is performed here. This is the action here. Okay. So S there is AB after action, then C. Here also see AB after, before going to C you have to perform the action. So for that what I did here, AB I have taken another variable X, and production should not be changed. For that reason I am taking X there is epsilon. X there is epsilon. In X place if you substitute epsilon, what will you get? A, B, epsilon, C. Is ABC only na? So production is not changing. And moreover, X there is epsilon. Here I write print A dot value something. So look at this one. At the time of reducing, you are performing, and it is a S attributed SDT. So like this, we can convert the L attributed SDT into S attributed SDT. That is your doubt, I think. Who is this one? Yeah, Ayush Vashishta. Okay, and similar one question is there in the workbook. So workbook questions I am not doing any, maximum out of these workbook questions I am doing only, you can search in the total of my CD class, maximum 5 questions or 4 questions, even not 4 or 5 also. So very less questions I am doing from workbook, maybe 3 or 4. Why I am not touching the workbook means I want to make you do all the questions with my class. That is the reason I am leaving all the workbook course solutions question. I am not touching any question. But you have the recorded video, and today's syntax analysis video will be uploaded. I have given already. So and tomorrow I will do the semantic, that is syntax data translation, and day after tomorrow I will upload that intermediate code generation, and next runtime environment. Okay. So coming to this one, X equal to A plus B star C minus D. So you observed here, this part is integer part, B, C, D are integers, X and A are the real. So what I do here, T1 equal to B star C, okay, B is integer, C is integer, and result T1 is also integer. Then T1 equal to T1 minus D, or you check T2 equal to T1 minus D. So we are not concentrating on the minimal number of variables. I don't want to confuse. So that is the reason I am writing T2 equal to T1 minus D. T1 is integer, D is also integer. Then T1 minus D is integer. Then if anybody has written that X equal to A plus T2, this is not correct. This is not correct, because A is real and T2 is integer. The result of T1 minus D, which is T2, is a real. So you should not operate between two different data types. So A is real and T2 is a integer. So what I do here, I will convert this into real of T2. Then it is perfect. So X equal to A plus into real of T2. Then this is the perfect answer. Okay. Next question. Third one. For X equal to 0, X less than or equal to N, X plus plus, A equal to A plus X, B equal to B minus X. So this is the code. For this code I want 3 address code. For this code segment I want 3 address code. Okay. So copy and try. Yeah, right. Right, Tuhi Bandopadiya, it's right. Yeah, Ashish Prasad Diyondi, right. So make it fast. So after this, So this is linear representation of intermediate code. What is postfix notation we have done, and what is 3 address code now we are doing. After this we will go for the tree representation. These are linear representation, then tree. In tree representation we have abstract syntax tree and DAG. DAG is very important. DAG is very important. If it is not mentioned in the question which operator, definitely they will give you one grammar. Grammar, based on the grammar you decide, because Kumar. Otherwise in general you take. If plus and multiplications are there, then you take the multiplication the highest priority. You do like that. But definitely they will give you grammar also. So if any test paper also, I think today it will be uploaded, today or tomorrow. First test paper compiler design. Compiler design test paper, you will have 2 test papers. One is lexical analysis, basics of compiler, and syntax data translation, I think. And another one is SDT and intermediate code generation, code optimization, runtime environment, like this. So first paper I have given very easily. So most of you get full marks. But second paper I made it a little bit tough, little bit. Then as you get the comparison questions, I will make it tougher level, easy, then average, then more difficult, then most difficult, like this. My plan is. So if anybody has done the test paper, means if you do the test paper in the future, just give me your opinion after you do the test paper of comparison first paper. So after you do every paper, you just share your experience with me in WhatsApp. Okay? Next, what is the 3 address code for this? X equal to 0, x equal to 0, then if x less than or equal to n, if x less than or equal to n, go to sum L, it's a label. Okay, now as long as x is less than or equal to n, you have to execute this one. Okay, so if x is less than n, I will jump to L. What is L? A equal to a plus x, b equal to b minus x, then you just run the loop. So for that what I do, x equal to x plus 1, then go to again this condition L. Okay, now x will be incremented, it will check. If x is less than n, it jump to this L, and again it will do this one, x will be incremented again, like this. After, because we are keep on increasing, so after some loop and some after some executions, this definitely will exceed, x value will be exceed n value, because every time we are in every loop we are means increasing the x value by 1. So after some time it will be crossed the n value. When x is not less than or equal to n, means x is greater than n. If x is once greater than n, if condition is true, as long as condition is true, it will execute this go to. If condition is false, means if x is greater than n, then it don't execute. It don't execute this loop. Then it will come to the next instruction. Next instruction, if I don't write anything, it will be executed, it will be executed, it will be executed, continuously. It will goes into the infinite loop. Am I right? Okay? And or go to L, and this one x is not less than n, then no instruction is there. Again it will be incremented, again incremented, even though condition is failed. Condition is failed. So actually go to L, instead of L it will come to the next instruction. If next is not there, automatically this will be executed. What I mean to say. So you have to come out of the loop. So for this reason I write the go to L, means you have to come out of the loop. Now look at this. I will give this as L1, and this as L2 and this as L3. So to look good, beautiful, I have given L1, L2, L3 in the sequence. I have given in the sequence. Okay. Now this is L2, this is L3. And if x is less than n, then less than or equal to n, you have to go to L2. You have to go to L2. So go to L2. If the condition is not true, then come out of the loop, L3. Okay. Then if condition is true, then L2, a equal to a plus x, b equal to b minus x equal to x plus 1. Then check the condition. Then for that, where you have to go? You have to go to this one. Go to L1. If condition is failed, it don't execute, it executes the next instruction. What is the next instruction? Unconditional jump. Unconditionally, you come to the L3, which is out of the loop. This is. So initially I have not given the L1, L2, L3. I gave L only, and after that I have came to the final conclusion that we have three labels. So I have given in the order L1, L2, L3. So this is back patching. Back patching means leaving the labels and filling them after. Filling them after is called as back patching. Okay. So the same code, if anybody wrote like this, that is also correct. That is, if x greater than n, then come out of the loop. How long shall we run this loop? Until x is less than or equal to n. If x greater than n, come out of the loop. So if condition is not true, means x is not greater than n. If x is not greater than n, are you following? Then it don't execute. It executes the next instruction. What is the next instruction? A equal to a plus x, b equal to b minus x, and x equal to x plus 1, increment the x value, then go to L. L means this one. Okay. So I will make this as L1. And suppose here x equal to x plus 1, then it jumps. X is greater than n. No. Then it don't execute. It executes the next instruction. Like this, after some time x will be incremented. X will become more than n. Then condition is true. Then come out of the loop. What is out of the loop? This is out of the loop, L2. So like this also you can write. So either this way or this way. So the logic is your wish. So same program can be written in different ways by the different students or different people. Okay. So either if you want to use the x less than or equal to n, this will be the. If you want x greater than n, this will be the. So whatever, and you may written the better than this code. Okay. So that depends. Okay, either this or this. You copy anything. So what is back patching? Copied? Yeah, of course. But suppose Praveen Kumar, if you write the exit, if something is there out of the exit means completely out from the code. If I write the L3, whatever the next part of this code will be executed. That is the meaning. That is the reason I wrote L3, Mr. Praveen Kumar. Of course, instead of L3, you can write the exit. Then exit means completely out of the program. समझ गया मिस्टर प्रवीण कुमार द डिफरेंस बिटवीन गो टू L3 and exit. Prajwal Boite, I don't know about this one. You don't ask any questions, any doubts regarding the other than subject. That test series included or not, I don't know. Really, I don't know. Rohit Sharma, I have given the 2 papers, 1 and 2. So only today only first paper is finalized with corrections, and second paper will be finalized tomorrow. So I think by tomorrow or day after tomorrow you will get the 2 papers. Rohit Sharma. Okay. And one more. Take back patching. Back patching. Take the heading back patching. Back patching is a process of leaving the labels Yeah, when x is greater than n, go to L2. It will be executed. It will be out of the loop. Who is this? When x greater, the loop will be terminated because it is for loop. Copied. Okay. Arshit Sharma, what is your doubt? Okay, test series included. Okay, it's good. So take back patching is a process of leaving the labels, leaving the labels, leaving the labels and filling them after. Leaving the labels and filling them after is called back patching. Okay, is called back patching. Now, I'll give you one more. Do this one fast. Fast. We are going slow. So in this two important topics are there. One is DAG and the other one is basic blocks. Basic blocks easy concept, and DAG also easy, and one more SSA. These 3 are easy topics but important also. I'm expecting this much. I'm strongly expecting this year. That is 23. For 23, we may get the question from basic blocks, that is control flow graph or DAG. But mostly I am expecting question from basic blocks, that is control flow graph. Okay, done? Okay, look at this one. I will do this. Okay. Simple. Nothing. This is not that much. If A is greater than B, go to L. Suppose A is not greater than B. Suppose this condition is failed. Then you have to execute this one. Yes or no? So when condition is not true, it don't execute. The go to means when the condition is true. If A is greater than B, the condition is true, satisfied, then only it comes to this execution of go to. If it is not true, means then it will come to the next instruction. So when A is not greater than B, you have to execute this one. So A equal to A minus 1 and B equal to B plus 1. Then you just hold on. Suppose A is greater than B. Suppose A is greater than B. That means the condition is true. Then it comes to go to L. L is this one. So if A is greater than B, you have to execute this one. A equal to A plus 1, A equal to A plus 1, B equal to B minus 1. Then next instruction. Now look at this one. If condition is true, I will go to L1. L1 is this one. Okay. If condition is not true, false, A equal to A minus 1, B equal to B plus 1, and go to L2. L2 is what? Out of this loop. This is L2. Okay. I will explain this one. If condition is true, go to L1. L1 is A equal to A plus 1, B equal to B minus 1. Then next instruction will be executed. L2. You need not write. After this, go to L2. Even though you write or don't write, the next instruction will be executed. If you want to skip, then only you use the go to statement. Look at this one. If A is not greater than B, condition is means false. A equal to A minus 1, B equal to B plus 1, then unconditional jump. If I don't write this go to unconditional, then it is also these two also will be executed. That is the reason either you do this, then go to L2, jump, or go to L1, then this one. Okay. So one more. This is final. If A greater than B and C greater than D, if A is greater than B and C is greater than D, then x equal to x minus 1. I think this braces, curly braces are not required, no? X equal to x plus 1, else y equal to y plus 1. So for this you just write make it fast. So after this we will go to abstract syntax tree and DAG, then SSA. So it is 715. Okay. Control flow graph, code optimization. Okay. Okay, done? Okay. Look at this. This one. If A is greater than B, and C is also greater than D, then only execute this. Otherwise you have to execute this one. Suppose A is greater than B, then go to L. L I write here. Then if A is greater than B, then check this condition also. If C is greater than D, okay, if C is also greater than D, then go to L. So what is L? I write here. So A is greater than B, then jump to this. C is greater than D, then execute this. X equal to x plus 1. Okay. Suppose A is not greater than B. Then you need not to check the C is greater than D or not. Do you understand? So if A is not greater than B, so what I do here, then go to, I write the go go to some L, okay, leave it, I will fill this after some time. Then suppose A is greater than B, then it comes to this, C is greater than D, then it goes to this. Suppose C is not greater than D, A is greater than B, but C is not greater than D, then it don't execute. Then either A is not greater than B or C is not greater than D, then you have to execute y equal to y plus 1, y equal to y plus 1, okay, y equal to y plus 1. Then come out of this, go to some L, okay, this is L. Now look at this one, A is greater than B, go to L1, this is L1. Suppose C is also greater than D, A is greater than B and C is also greater than D, then what we want to execute, x equal x plus 1. Where is x equal x plus 1? This one, go to L2, this is L2, this is L2 na? No, this is this is L, this is L2, this is L3. So go to L3, this is L3. So labeling, you need not to give the order, you can give any order. I repeat this one, if A is greater than B, then go to L1, this is L1. If C is also greater than D, means both the condition is true, then go to L3. If both the condition is true, x equal x plus 1, x equal x plus 1, then automatically it will come to the next line. Suppose A is not greater than B, then you have to execute y equal to y plus 1, this y equal to y plus 1, L2. Suppose A is greater than B, but C is not greater than D, then it won't execute L3. Then next instruction, y equal to y plus 1, then come out of the loop, that is L4, this, not loop, out of this one. So this way, and of course you may written a better than this one, okay. The code, it need not be the same, but I am giving you the general idea, okay. Just copy. If anybody has written the better one, just you keep it. No, you cannot write. Aryan Jaiswal, no. Copied? Copied. Now we go to next one. Yeah. This is, so we have done this postfix notation, 3 address code. Now tree form. What is the tree? What is abstract syntax tree? What is abstract syntax tree? What is directed acyclic graph? I will tell you. Okay. Done? Next, parse tree. What is parse tree? What is sparse tree? Now, already actually the tree can be either parse tree or syntax tree. Tree can be either parse tree or syntax tree. Okay. In syntax tree, it can be abstract syntax tree or directed acyclic graph. So tree can be either parse tree or syntax tree, and coming to syntax tree, it can be divided into abstract syntax tree or directed acyclic graph. What is parse tree? What is parse tree? So look at this example, very known example. You have seen several times this example, E derives E plus E or E star E ID. So for this I am constructing one parse tree, one string, E derives E plus E and E derives ID, and here E star E and E derives ID and E derives ID. Suppose its token value is x and its token value is y and its token value is z. So what is the expression here? X plus y star z. Yes or no? X plus y star z is the expression for this tree. So this is a parse tree. This is a parse tree. Now what is the syntax tree? What is the syntax tree? What is the syntax tree? In syntax tree, the internal nodes will be hidden. The internal nodes, these all internal variables, these all internals will be hidden. So this is parse tree or concrete parse tree. You can say it has a concrete parse tree. What is syntax tree? The syntax tree for this is x plus y star z, x plus y star z. In syntax tree, the leaves, whatever the leaves, these are the leaves. These leaves are the variables, or you can say identifiers or constants. In syntax tree, the leaves are variables or constants, and the internal nodes, these are the internal nodes. The internal nodes are operators. In syntax tree, the internal nodes are operators and the leaves are either variables or constants. Okay. Whereas parse tree, everything we will show. And in the syntax tree, these are hidden. These will be hidden. So we don't represent these internal variables. Do you understand? So that is the difference between syntax tree and parse tree. Parse tree or concrete parse tree. Parse tree or concrete parse tree, both are same. Copy? Copied? So this is tree, parse tree and syntax tree. We have seen the difference between parse tree and syntax tree. Now we will go for abstract syntax tree and directed acyclic graph. Okay, make it fast. This one. Now, it is syntax tree as well as abstract syntax tree. This is syntax tree as well as abstract syntax tree. So, what is the difference between abstract syntax tree and directed acyclic graph? Okay, in abstract syntax tree, yes, a node we can create any number of times. In abstract syntax tree, any node you can create any number of times as per the requirement. Example, simple. X plus x. So what I do, I will consider like this, x plus x. Do you understand? X plus x. This is abstract syntax tree. Whereas in DAZ, if a node already created, yes, x is we have created x here. Again we are creating one more time x. But in DAZ we don't create any node repeatedly. Do you understand? The leaves, I am talking about in DAG only leaves, and internal operators you can create any number of times. So in the internal operators also, if I create, if you want to create only one time, you cannot construct the DAG for every syntax tree, every expression. The internal nodes, these are the operators. Internal nodes are operators. Operators can be created any number of times as per the requirement. But the leaves are, what are the leaf nodes? This X, Y, Z. So these leaves will be created only once. Example, X plus X. X plus X. For abstract syntax tree, you can create X here. Again, we are creating. So a node can be created any number of times. Whereas in DAG, once already we have created this X, and so whenever you need the X, whatever the node we have created, that node only we will make use of it. We don't go for the creation of the same node again and again. So how DAG will be for this? How DAG will be for this? So we are creating X, we have created X. So this is the plus node, this is X, X plus X, that is the DAG. So in DAG, if a node is once created in abstract syntax tree, you can create, example, X plus X is there, X plus X is there. So what we can do, you just take one more plus and you take this X. So X plus X plus X, this is the abstract syntax tree. But in the case of DAG, if you need one more X, then already we have created that, we will make use of it. Do you understand? So in DAG, a node once created, we will make use of that created as long as you need. That too, leaves are where constants or variables, not talking about the operators. Look at this operator we have created here, and same operator we are creating, because it's without creating this you cannot go for DAG. Okay. Now, and moreover, DAG is the representation of this intermediate code. So in intermediate code, we will take only 1, 2. So plus you cannot take like this. Do you understand? So any node will have 3, 2 nodes, operands only. Okay, 2 operands only. So copy this one. Copy this first. Then I'll give you the definition of DAG. Then we will go for questions on DAG. We don't do the questions on syntax tree much. The main important thing is DAG. DAG is very important here. So different expression I'll give you. So how to consider the DAG for this, and they can ask you the question like this: number of nodes, these are the nodes, and number of edges, these are the edges. 1, 2, 3, 4. So for X plus X, how many nodes are there? Minimum nodes. So 1, 2, 3 nodes. How many edges are there? 1, 2, 3, 4 edges. They can ask you like this. So the minimum number of nodes and edges for the expression X plus X. So 3 nodes and 4 edges, the answer. Okay. So copied. You copy this and this, then this. Then I'll give you, this is the difference between parse tree and syntax tree. So we have done the parse tree and syntax tree. Now we are going for abstract syntax tree. Abstract syntax tree is nothing but a syntax tree only. Make it fast. No, you cannot take like this. Ujjwal Talian, you cannot take. It cannot do. A greater than B and C greater than D. No. Copied? Copied? So come to DAG. Directed acyclic graph. Directed acyclic graph. Directed acyclic graph. Directed acyclic graph. DAG. Directed acyclic graph. Take directed acyclic graph. Now take the notes. In DAZ, if a node is created once, if a node is created once, instead of going for the creation of the same node, we will make use of already created node. DAZ is used for common sub-expression elimination. DAZ is used for common common sub-expression elimination. Okay. Now, next, continue. In DAZ and also in syntax tree, you can say in syntax tree. Syntax tree means either a abstract syntax tree or directed acyclic graph. In syntax tree, the leaves are either variable names or constants. In syntax tree means either abstract syntax tree or directed acyclic graph, DAZ. In syntax tree, the leaves are either variable names or simply either variables or constants. The internal nodes will be operators. In syntax tree, the leaves are variables or constants and the internal nodes will be operators. So directed acyclic graph won't have any cycles. In DAZ we don't have any cycles. Okay. So if you want to copy, you can copy this one. X plus x plus x. I think I have given this one. Yeah. Okay, differently I have given. So you just copy if you want. Otherwise leave it. Make it fast. If you are copying this, make it fast. And this is abstract syntax tree. And the expression is x plus x plus x. Done? Copied? Okay, now. So write the syntax tree and DAG for these two. Syntax tree and DAG. What is the syntax tree? X equal to x plus a. This is syntax tree. Yes or no? This is syntax tree. X equal to x plus a, syntax tree. Then what is the DAG? What are the DAGs? Have you observed here? This x and this x we have created twice. But in the case of DAG, we don't create the same node again and again. So first of all, is this x plus a or x equal to x? First of all, you have to evaluate x plus a. So what I do? First I will add x, these two nodes x and a. Now this result is we have x plus a. So this must be equal to So this must be equal to x na, x equal to na. So where is x? Already x we have created na. So we take this one. Do you understand? So actually this result equal to x, it must be x. But instead of writing this x, already we have created na. So that is the reason we are taking this one. So this is DAG. So the nodes and edges may be more in syntax and in syntax tree. The nodes and edges may be more. Maybe means why I am saying maybe. So every expression will not be lesser in DAG compared to syntax. Example, if it is y plus a, then both will be same. Do you understand? Here x is there, that is the reason we are reducing. If it is y plus a, then DAG and syntax will be same nodes and edges. Okay. Now this same as this one. So I will do this fast. X equal to a plus a, x equal to a plus a plus a, and this whole is equal to x. Yes or no? This is syntax tree or abstract syntax tree, whatever. Abstract syntax tree or syntax tree. Now what is the DAG for this? A plus a, again one more plus a, then this is equal to x. So this is the DAG. Got it? So DAG and abstract syntax tree. Any doubt? Okay, I'll go. These are simple concepts. So the complicated one we are going slowly, we'll go to the complicated one. This is syntax tree and this is DAG. Okay. Next, I think you have copied this. Make it fast, guys. Next one. Take this one. So you just take the B star C, then result add to A and result subtract from A, and finally this is this by this. Here parentheses are not required to represent in the DAG. So to for the clarification only I have given this parenthesis, but in the DAG repetition you don't use the parenthesis. Make it fast. So here you just go for directly the DAG, and you know how to consider the parse tree. So simultaneous, I'll consider the parse tree here. What is the parse tree for this? This is B star C, and this is A plus B star C. Okay, A plus B star C, and here B star C, and this is A minus B star C. This is A plus B star C. This is A minus B star C. So this by this by this. Now, so I will take this one, this by this. Okay, and this whole result I want in X. So this is the abstract syntax tree or syntax tree. Abstract syntax tree. Abstract syntax tree. Okay. Now what is the DAG for this? What is the DAG for this? B star C, B star C, okay, and then A plus B star C, okay. Is it okay? A plus B star C, that is done. Now look at this, guys. We want A minus B star C. A is here, minus B star C here. So now look at this. This is A plus B star C. I want A minus B star C. A is here. Already we have created. So take the minus. Minus is the node. A minus B star C. B star C is here, na? So that is A minus B star C. Now, this is first part. This is here. We have. Suppose this is T1. And this is T2. So T1 is here. And T2 is here. Are you following? This is A plus B star C is here. T1 and A minus B star C here T2. So we want T1 by T2, T1 by T2, T1 by T2. That's it. Now this whole result we want in X. So X is is it created? No, it's not yet created. So if it is not yet created, you just go for the creation of the node. Now this is X. If it is created, we will make use of that. So that is the DAG. Okay, so DAG and copied. Now we'll go for next one. Copied. So whenever I just say same question you are repeatedly asking, precedence is not given, then general you go for it. General. So if you have plus and multiplication, plus and star, then go for the star more priority, then go for plus, like that. And you know that suppose here, so this will be, first you have to evaluate this one, then evaluate this one, finally you do for the go for the division. So if they want to exclusively, if they want to give the priorities, they will give the priorities by giving the grammar or by mentioning the priorities. I have given one question in this test series, you can see that, okay, based on this. There I have mentioned. I mentioned means I may give the operator's presidency directly, or I may give you based on the grammar. So means I give the grammar. Based on the grammar you decide. Next, this one. Make it fast. You just consider the DAG. I will consider only DAG. I don't go for the syntax tree. I don't go for the abstract syntax tree, because abstract syntax tree easy you to construct. Ayush, here not needed. The direction is not needed. No need to represent. DAG won't have any cycles. It won't have any cycles. Okay, now. So, clearly it is given B minus C. So, B minus C, B minus C, B minus C, then A star B minus C. This is done. This part is done. Okay. And this part B minus C into D, B minus C into, so D is not created, go for the creation of the D. Okay. B minus C into D, this is A star into A into B minus C. So we want plus of this this expression and this expression. So I will take the plus node here. Then this whole I want to add to A. So I will take another plus node and A is here. So that's it. Simple. So how many nodes are there here? 1, 2, 3, 4, 9 nodes are there. How many edges are there here? How many? 10? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 nodes. Okay. 9 nodes and 10 edges. 9 nodes and 10 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9 nodes. 9 nodes and 10 edges. 10 edges. Edges are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 edges. Okay? I think it is clear. It's no need to explain this again and again, because from last 20 minutes we are doing the same. So this is B minus C, A star B minus C, B minus C star D. So this part add, and final this whole part to add to A is here. So this is DAG. Next. The number of nodes in the DAG for the following expression. The number of nodes in the DAG for the following expression. So look at this. Is it clear? Is it visible clearly? I have increased the font. So try this question. You need not to mention the associativity. According whatever you consider the past DAG, that DAG it will the based on whatever the intention, accordingly it will be executed. Here what I mean to say is, based on the priority, based on the priority only we are constructing the DAG. Associativity not required, but of course A minus B minus C, so definitely difference will be there. A minus B minus C, A minus B minus C, and if you do this first and then this one, you will get one answer. At the same time, A minus B minus, if you do this first then this, you will get. So actually if I want to do this and if I want to do this, what is the difference here? A minus B, look at this, mister. Somebody is asking, this is A minus B, yes or no? Then minus C. Do you understand this one? That is the reason I am saying the DAG, it gives you everything clear. Suppose I want to do this, mister. I want to do this one I want to do. So B minus C, B minus C, and then A minus. Do you understand the difference between here? This is A minus B minus C, whereas here A minus A minus then B minus C. or B minus C, which is subtracted A minus. Okay, this part is B minus C, this part is B minus C, and here what is this? A minus this part, B minus C. Okay, this is this one, and this is this one. So everything is clear. So don't think that the same DAG will give different expressions. A DAG will give only one expression. So this is the DAG, and for this is the DAG. So definitely here associativity is there, and priorities also will be there. Eight nodes. Are you sure 8 nodes? Let me check. 1, 2, 3, 1, 2, 3. Okay, this is 4 and 5, 6, 7, 8. Yes, 8 is correct. Okay, let me check. X plus y. X plus y, this part, into this part. Am I right? X plus y. X plus y into x plus y. This is x plus y into x plus y. Now, we want to subtract this whole from x plus y. This whole is here. So, subtract this from x plus y. Where is x plus y? This one. Okay, this is done. Now, here x plus y star x plus y. Here we have this x plus y star x plus y. This you add to this whole. So, what I take? I will take plus and I will add this 2. Do you understand? The result is here. Am I right? X plus y minus this one. Here we have this result. Suppose this is T1. Okay, T1 is here, and that is T2. T2 is here. T2 is what? X plus y into x plus y. So T1 plus T2. This is T1 plus T2. I am taking T1 plus T2 as T3. For this T3, you add T4. This is T4. What is T4? X plus y divided by x plus y. X plus y divided x plus y divided by x plus y. This one. Yes or no? X plus y. This is C. What is the meaning of this one? What is the meaning of this one? A by B. Yes or no? A by B. What is A? X plus y. Which is x plus y. What is B? X plus y. What is B? This one. X plus y. Now, so this is T4. T4 must be added to this one. This is T4. So add to this one. Okay. So finally, how many nodes we have? Let me check. 1, 2, 3, 4, 5, 6, 7. I have missed one thing. Something I have missed. Yeah, I got it. What I missed? See, actually, this is here na T1, and this is T2. T1 plus T2 is here. So for this whole, you must add this T4. So take one more. That's guys. Okay. So this is x plus y into x plus y, x minus y into x minus y. This is x plus y minus of this one. Then x plus y into x plus y. This will be added to this part. So this one, and x plus y divided by x plus y, this one. So this whole add to this one. Okay. So finally you will have 8 nodes. 1, 2, 3, 4, 5, 6, 7, 8. Answer 8. So how I have counted this without constructing the this DAG earlier. Simple. X and Y already we have created X and Y. So 2 will be there, 2 nodes. For plus, this is 1, 2, 3. X plus Y already we have, na? X plus Y, we will make use of this one. So this is X and Y, 2 nodes. This is third one, fourth one, this is fifth one, okay, and this is sixth one. Already we have this, okay, sixth one, and this is seventh one, and X plus Y already we have, and this is eighth one. That's it. 8 nodes are there, okay. So without constructing the DAG also you can go for the finding the number of nodes, but you must be very careful, okay. So there is a chances making mistakes in that without considering the DAG, okay. So next, this is a different kind of construction of the DAG. Here till now I have given a single expression. Now what I do, I will give you the 3 address code. You know what is 3 address code? 3 address code means a sequence of 3 address statements. So if I give you 3 address code, for that 3 address code segment, it is a 3 address code segment. For this 3 address code segment, what is the DAG? Okay, just copy this. The minimum number of nodes and edges in DAG for the following code segment. Copy. I already told you this one, Priceable Boilte. Operators you can use any number of times, but only the leaves you cannot construct multiple times. Where are the cycles here? Okay, now look at this, guys. How to construct? If whenever they ask you the question, they ask you for the minimum number of nodes and edges. If they don't ask you the minimum number of nodes and edges, okay. And moreover, whenever you are constructing the DAG for a given 3 address code, first of all you just identify the common subexpression. What is the meaning of common subexpression? That means if once an expression is executed, if any expression is executed, example x equal to a plus b, now c equal to b plus 5 and y equal to some a minus b and z equal to a plus b. Okay, now look at this, guys. Look at this one. Here a plus b we have executed, and this result we have in x. Okay, na? Look at this carefully. A plus b we have evaluated. That value we are storing in x. What is the meaning of common subexpression? Okay. Next is b plus 5. We are adding b to the 5 and we are storing in c. Next we are subtracting a and b. We are adding to y. We are copying to y. Okay. Then a plus b. Again we are adding a plus b. We are adding a plus b and we are storing into z. Already a plus b we have evaluated and that is available in x. Again why should we evaluate a plus b here also? Unnecessarily wasting the time. So what we do, c equal to b plus 5, y equal to a minus b and z equal to a plus b. A plus b is available in x. We do like this. A plus B is available in X, and this is called common sub-expression elimination. That means if an expression is once evaluated, computed, the same expression if it comes again and again, instead of evaluating every time, already we have evaluated that value, we will make use of here. But there is one thing you have to notice. So here A plus B is given now, and here A plus B already we have executed. Now in between A and B value should not be changed. That means suppose here I gave like this. Here whatever A and B values, and after this A value we are changing. Suppose here A value is 2 and B value is suppose 3. A value is 2, B value is 3, and A equal to B plus 5. What is B value? 3. 3 plus 5, 8. Now A is becoming 8. But earlier what is 2? What is A value 2? Are you following? Here A value 2, suppose B value 3, and after execution of this one, what is the X value here? X value will become 5. Yes or no? Now A equal to B plus 5. B is what? 3. 3 plus 5. This will become 8. Now when you come to this one, here A value is 8 and B value is 3. 8 plus 3 almost 11. But so you cannot use this because X value is 5, but actually Z value is what? 11. So whenever you are doing any common sub expression, that value should not be changed. See, X value, X equal to A plus B, then C equal to B plus 5, then Y equal to A minus B. So from here to here we have not changed the A values or B values. Then you can eliminate this. And then you can write Z equal to X. This is called common sub expression. Now look at this code. Here, do we have any common sub expression? A equal to B plus C. Hello, are you following? Then C equal to A plus D. D equal to B plus C. Here B plus C and here B plus C. You may be thinking that both are same. Yes, of course, both are B plus C. But whatever B and C values, here B and C values, here and here both are not same. Here C value, whatever, when you come to this one, we are changing the C value. There is no common sub expression. Do you understand? Here whatever the B plus C, that B plus C, whatever the value, when you come to here B and C, the values are not same because in between you are changing the C value. So you cannot say that there is a common sub expression. Okay, even though B plus C, then A plus D, nowhere. So there is no common sub expression. Do you understand? Now, how to construct the DAG for this? Simple. A equal to B plus C means you take the B, create the B plus C. Okay. Now this value is A. When you have the sequence of 3 address statements, we don't use separately equal to A. If you take equal to A, for this also you have to represent A equal to C. So multiple equations won't be there in any expression. Only one equal to will be there. So that is the reason we don't use the equal to if an 3 address code is given. So this B plus C will be given. Now this B plus C is here A. Now A plus D. Where is A? This is A. And D, do we have we considered the D? No, we have not created the D. So what I do here? I will create the D here. Are you following? A equal to B plus C. B plus C is here A. And A plus D here. What is A plus D? C. So next sequence, whenever you get the C value, so every time take the latest value. The latest C is this one or this one. This is the latest C. Are you following? So C already we have created here, but C equal to A plus D. So this result is C. Now this is the latest C. So after this, whenever you get the C, you have to use this C only, not this one. Okay, this is done. Now look at this one, B plus C. Where is the latest B? This is the latest B. And where is the latest C? This is the latest C. So take B plus C. What is this B plus C? This is D. Next, after this, whenever you get the D, don't use this D. You use this latest D. Okay, then D minus B. Look at this, D minus B. So this is D, this is latest D minus B. B is where? Here. Okay, this is done. then this is equal to E. This is equal to E. Are you following? Then A equal to E plus B. E, this is E, and plus B. Where is B? This is B. This is the latest B. And this is equal to A. So this is the final answer. But this is not the correct answer. Are you following? This is the top down approach. Top down approach. So whenever they have asked for the minimum number of nodes and edges in the DAG, we will go for the bottom up approach. In top down approach, of course, this is a DAG, no doubt, but the result, the minimized number of nodes and edges may not be, the number of nodes and edges in the top down approach may not give the minimized one. So we will go for the bottom up. Whenever they have asked the question, you go for the bottom up approach. What is the bottom up approach? I will tell you. You just copy this one if you want. So make it fast. Make it fast. So this is A equal to B plus C. This is A plus D, which is C. Then B plus C, which is D. Then D, this is D, E minus B, D minus B, D minus B. D minus B is E, this is E. Then E plus B, this is E plus B, it is B, and which is equal to A. The final result is A. Okay? Got it? Fast. Make it fast. Copied? Internal operators, internal nodes are operators. Operators can be used many times. Otherwise, you don't get the perfect answer. So how can you use the same plus for year and year? So which gives you a different answer, final answer. So internal operators are, you can create any number of times. Mr. Somebody is asking me. No, they never ask you the maximum. They never ask you for maximum. Praveen Kumar, always they will ask for minimum. Of course, if you want to get the question for maximum, then go for the better top down. But never they ask you. Okay? I am deleting. I have deleted. Okay? Copied? Now we'll go for bottom up approach. Bottom up approach. What is the bottom up approach? Take the last one. What is that? E plus B. A equal to E plus B. It is very simple. Very simple. Okay. Take the last one. E equal to A plus B. Okay, we have taken. Then come to the next. Next is what? E. What is E value? D minus B. So in E place, when you are going from bottom to top, take the last one. Then next one is E. In the E is what? D minus B. So in E place, we will substitute D minus B. Do you understand, guys? Hello. After A, next value is E. What is E? D minus B. So in E place, I have substituted D minus B. And minus B plus B will be cancelled. Now D. Next come to next one. Bottom to top. Next D. D equal to what? D equal to what? B plus C. So this is done. Then go for C. What is C here? B plus C is what? A plus D. Okay, we have gone. Then go for A. What is A here? In A place. B plus C plus D. Okay. Then we have reached. Again, sir, B I substitute this one and C I substitute. No. You are coming from bottom to top. That's only one cycle. Don't go for the repetition. Okay. So in A, we have taken A. Then in E place, we have substituted D minus B plus B cancelled. We have D. In D place, next level D. D plus B plus C we have. Then next level C plus A plus D. Next A place, in A place B plus C. Now this is the final expression. This is the final expression. Now what is the result here? What is the result? So here this is, you can take B plus B plus B. Is this the B plus B? Hello, is this the B plus B? Yes, this part is done. Plus C. So create a node. C is not there. Then this is done. Plus D. So create a D. D is not there. Okay, and this is done. So B plus B. This is B plus B plus C plus D. That's it. Again, you don't take star. This is A equal to, I will write A equal to this one. No, don't write this one. Okay, don't write this one. So this is the final. So how many nodes we have? 1, 2, 3, 4, 5, 6. 6 nodes. 6 nodes. And how many edges? 1, 2, 3, 4, 5, 6. 6 edges. 6 nodes and 6 edges. This is the best one. So I think it is clear. Okay. So bottom up approach, take the last one. And when you going to next E, so to substitute. Next D, substitute. Next C, substitute. Next A, substitute. If you have any minus and plus, you just cancel. And final. So B plus C plus D. That's it. Simple. Okay. This will be given for 2 marks. Okay. Next. Copy. Make it fast. आयुष महेश्वरी सर, आज क्लास जल्दी लीव करेंगे क्या? नहीं. ओके, आप थोड़ा जल्दी मतलब रोज धीरे धीरे बोल के मेरे को बोर लग रहे हैं. So and these are the easy topics. That is the reason I am going little bit speed. If you want me to decrease, okay, I'll decrease. Okay, Ayush Maheshwari. So every concept I cannot teach slowly, na. So the parsing techniques are little bit tougher. That is the reason so many students have asked me repeat. That is the reason I have gone slow. And these are the easy topics. Abo, one more. Praveen Kumar भी पूछ रहे हैं, सर इतनी जल्दी में क्यों हो आज? मतलब am I not reaching you? Means are you not able to understand? Praveen and Ayush Maheshwari, are you getting or not? See, I am giving the explanation. Oh, decrease. Okay, I will decrease. Keshav Gaur, I will decrease the speed. Actually, this is my original speed, but many of people are asking. That is the reason I have decreased the speed till yesterday. Okay. Actually, whenever we do the questions fast, it will give you more means like what do you call? I am not getting the word. Okay, spirit. So we will and see the syntax analysis questions, the recorded video. I have gone little bit speed some questions, but see all the concepts we have done in the class. And you can observe also whatever the questions in the workbook, they are not matching with the classroom questions. 90% are different. I think more than 90% the questions are different in the workbook. So intentionally I have not touched any question from the workbook. So whatever we do in the class, if you, based on that, if you can do the workbook, that means yes, you are getting the concept. I means I am reaching you. Okay. Next, the minimum number of nodes and edges. Go for this. A equal to not is we don't write, because all these we have done based on the 3 address code. So 3 address code, whenever it is given, we don't take A equal to finally. So it's raining outside Delhi. Okay, I mean inside na, I don't know what is, whether it is raining outside or not. Rajneesh Maurya, don't ask me these kind of questions. What will be there if E equal to A plus D in the second expression? That will be a different. If you change the question, the answer will be different. See, we are doing more questions. This is the next question. You try. See, actually I am not going fast today. I am talking fast. I am speaking fast. But the actions are slow only. So the concept, see till what, now we have crossed the 2 hours, now it is 8:20. What we have done till now, what is the 3 address code, different statements, based on the 3 address code we have done the enough questions. Then what is abstract syntax tree, what is the diag, that's it. Okay, I will ask them to upload the video immediately. Harshish Sharma. Oh, is it heavy rain outside? Actually, from afternoon onwards, I have not gone outside. I was doing the videos here. So I don't know whether it is raining or not. But anyway, Delhi is good. I like this Delhi. Okay? Got the answer? So D equal to A minus D. What is the answer here? What is the answer here? I'll go for this top down. B plus C is A, then A minus D is B, yes or no? Then B plus C B plus C, B plus C, and moreover, before going to this, you must go for what do you call common sub-expression, na? Anyway, this is what? This is B. This is B only, na? And B plus C not same. Okay. I am going to top down. And anyone is thinking that this is B plus C, this is B plus C and this is B plus C. Both are not same. Why? Because here B plus C and B plus C before, in between B value we are changing. So there is no common sub-expression in B plus C. But A minus D and A minus D both are same. Whatever A and D values here also same. So this is D equal to B. Okay, I am going to bottom, top to down. A equal to B plus C. A equal to B plus C. Okay, done. Then A minus D. This is A minus D. This is B. Okay. Now, so this is done. This is done. C equal to B plus C. This is latest B plus C. Do we have C? Yes, we have C. And this is the result. And D equal to B. Where is D? Where is B? Here. So this is D. Now what is the answer here? 1, 2, 3, 4, 5, 6. 6 nodes. 6 nodes. And how many edges? 1, 2, 3, 4, 5, 6. 6 edges. 6 nodes and 6 edges. So whenever you are doing, you just identify the common sub-expression. Yes, common sub-expression is there here and here. Okay, do you understand? Okay, A equal to B plus C, A equal to B plus C. Okay, this is done. Then A minus D, this is the A minus D, which is B. Okay, then B plus C, this is the latest B, this is the latest B, plus this is the C. So B plus C equal to C, this is the latest C. Then D equal to B. So B is here. So both B and D are same. So 1, 2, 3, 4, 5, 6 nodes and 1, 2, 3, 4, 5, 6 edges. So copy this one. So this is, so I cannot decrease this speed than this one. So I must speak very slowly. B plus C equal to A. Okay, got it? So once one topic I have explained clearly, then based on the same topic, if I am giving the same questions, then you must do it quickly. Okay, now I'll go for the bottom up approach. Okay, and moreover we have the common sub expression. Yes or no? Then what will be this? What will be this? Here A equal to B plus C and B equal to A minus D, C equal to B plus C and D equal to what? A minus D, which is B. Okay. Now I am going bottom up. I am going bottom up. So D equal to B. So don't take the single one. So take the C. C equal to B plus C. C equal to B plus C. If I take D equal to B, I have to skip this one. Then I cannot come down. Whenever you are going, you just go in this direction only. So D equal to B, leave it. Then C equal to B plus C. C equal to B plus C. And even the final value is here C. The final value is this one, C. Now C equal to B plus C, done. Then next go for. Next, are you following, guys? Hello. So this is D equal to B, the single. Don't take D equal to B, both are same. So in D place, in B place or in D place, we will use, this is nothing but D only. So that is the reason I am skipping. If anybody, why are you skipping? Because D and B both are same. Here B we have. Now next C, C equal to B plus C. And what is B? B is A minus D. A minus D. Okay, this is done. Then go for next one. A. What is A? What is A? B plus C minus D. It's okay. A is B plus C, then minus D, then plus C. Now take this one. Construct the. Now B plus C. B plus C. Am I right? B plus C. Yes, it is right. Then minus D. Take the minus and D is not there. Then create it. Okay. It is done. It is done. Plus. So take the plus operator and C. C. Already we have a C. Then go for this one. So this is done. So how many nodes and edges? 1, 2, 3, 4, 5, 6. 6 nodes. Edges 1, 2, 3, 4, 5, 6. 6 nodes and 6 edges. So in this case we got the same. Okay. Next. Govinda Mishra, sir, you should go once outside and eat Delhi's momos. So place, what is the nearest place to Saket? Momos? Yeah, we can do both top down and bottom up, but always bottom up will give you the minimum one. Sudeshna Rakshit. Hello, Praveen Kumar. I done the bottom up. I think you are very faster than me. Huh? First I done the top down and then bottom up. Both I have explained, boss. Okay. So after the break, we'll continue this one. We have more questions. This is one more question, and 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 this is the last question. So I am giving you enough questions. So based on this class, you can do the questions, whatever you get from other sources or in the examination. Okay. Then after this, we will go to control flow graph. That is also easy topic. Easy topic. Okay. There is no such any confusion. So process is there, procedure is there, but I will tell you the procedure very clearly, then you can enjoy the class. Okay. Thank you, and take the break only 15 minutes. Is this enough? 15 minutes break. So go for 15 minutes break. Now it is 8:30. Okay, 20 minutes. I don't want to suffer you. Okay. So 20 minutes break. 20 minutes break. My time is 8:30. So come back exactly at 20 minutes. Okay.